A number, when divided by 61, gives 27 as quotient and 32 as a remainder. Find the number. The question is very simple. Let's solve it. So first we will add solution. Next you can see here divisor equals to 61, quotient equals to 27, and remainder is equal to 32. So what do we need to find? We need to find the number. So by Euclid's division lemma, we have dividend equals to divisor into quotient plus remainder. And divisor, quotient and remainder is already given. So we have to input the value here. Divisor 61 into 27 and the remainder plus 32. And you can see here 61 into 27 is 1647 and plus remainder 32, so the total value is 1679, and this is the number. And you can see question number 3 is same as question number 2. Now let's see question number 4. Using Euclid's division algorithm, find the SCF of 612 and 1314. So here we'll be using Euclid's division method, and the process is very simple. Let's see solution. So to find the SCF of 612 and 1314 using Euclid's division algorithm, 31314 is equal to 612 into 2 plus 90. So what we are going to do here is we need to multiply the greatest number with the smallest number, and then we have to add the remaining. Again we'll follow the same. Now 612 is equal to this remainder 90 into 6 plus 72. Still we haven't got 0, and we will continue this process until we get the remainder as 0. So now again 90 is equal to 72 into 1 plus 18. Still we don't have 0. Again we'll go further. 72 equals to 18 plus 4, 18 into 4 plus 0. Now you can see finally we got 0 as remainder. So here, since the remainder becomes 0, the last non-zero remainder is HCF. The answer is 18. And you can see, therefore GCD 612 and 1314 is equal to 18. After doing this question, the question number 5 and question number 6 is as same as question number 4. Now let's go to question number 7. In question number 7, for any positive integers n, prove that n cube minus n is divisible by 6. The question seems to be very tricky, but it's very easy. Let's solve it here. Solution. The first, factorize the expression n cube minus n, and you'll get n as common and n square minus 1 as the remaining factor. Now again you can see here n square minus 1 can get more factors further, like a square minus b square. So now using the identity n square minus 1, we can write n plus 1 and n minus 1. So the final factorization of n cube minus n is n plus 1, and another one is n minus 1. Now this is the product of the consecutive integers n minus 1, n and n plus 1. Yes, you can see this is the consecutive integers n minus 1, n and n plus 1. Now you might be thinking something like one number is always divisible by 3 when you have 3 consecutive number. But again, at least one number is even. When there is three consecutive number, one number is always even. That means it should be divisible by 2. So let's go ahead. Therefore, the product n minus 1, n and n plus 1 is divisible by both 2 and 3. And the product of, since 2 and 3 are co-prime, the product must be divisible by 6 because 2 3 times is 6. Hence n cube minus n is divisible by 6 for all positive integers n. So n cube minus n is equal to n plus 1 and n minus 1. This is the answer. Now let's see number 8. Prove that if x and y are both positive integers, then x square plus y square is even but not divisible by 4. So you have to prove that there should be any positive integers. Then x square is y square is even but it cannot be divided by 4. Seems to be tricky but very easy. Let's see. Solution. Given that x and y are odd integers, we know that every odd integers can be written as x equals to 2m plus 1 and y is equal to 2n minus 1. For some integers m and n, after squaring both sides, we get x square equals to 2m plus 1 the whole square, which is equals to 4m square plus 4m plus 1. Again you can see this 4m can more be factorized further. So you can see x square equals to 4m will be taking common in these two terms, and 4m is equal to 4m m plus 1 plus 1. Now, since 4m m plus 1 is divisible by 4, x square is congruent to 1 by mod 4. So, if you don't know mod 4, just comment below. I'll make another video. What is mod 4 over here? And this congruent one is remainder 1. These three parallel lines are not equals. Okay, these are called congruent. And here similarly y square is also congruent to 1 by mod 4. Therefore x square plus y square congruent to 1 plus 1 by mod 4, which is x square plus y square is congruent to 2 by mod 4. Hence x square plus y square leaves remainder 2. This congruent is known as remainder 2. Okay, remainder 2 when divided by 4. So hence it is divisible by 2 if it is even but not divisible by 4. Then x square plus y square is even but not divisible by 4. This is the answer. Okay. So this is the answer of question number 8. Now let's see question number 9. Use Euclid's algorithm to find the HCF of 1190 and 1445, expressed in the form of 1190m plus 1145n. So we have a solution. So before solving this in Euclid's algorithm, first let's see the division of 1190 and 1445. So we have done these divisions earlier in our primary school and middle schools. Yes. So this will help us to find. This will help us to solve this question. So here, using Euclidean algorithm, 1145 is equal to 1190 into 1 plus 255. Now we will factorize this 1190 now. So 1190 is equal to 255 into 4 plus 170. Now we will factorize this 255. So 255 equals to 170 into 1 plus 85. Now we will factorize 170. Here 170 is equal to 85 into 2 plus 0. So finally you can see we have got the remainder 0. Yes, and we have discussed in earlier video that the non-terminating the non-zero of the factorization is an HCF. So you can see here the HCF is 85. So we have got the HCF, but the question is asking express in the form of 1190m plus 1445n. So here now expressing 85 in the form of 1190m and plus 1145n, here working, let's work from backwards. Okay, working from backward, we can write 255 equals to 1445 minus 1190, this 255, and this 170 we can write as 1190 minus 225 into 4. Yes, after that when we substitute onto 85 is equal to 255 minus 170, and again we get 85 is equal to 255 minus 190 minus 4 into 255, or we can write 85 is equal to 5 into 255 minus 1190, because 1 come from here also. Yes, this is 4 and we got here 1 5. After that again substitute 85 is equal to 1145 minus 1190, or you can write 85 is equal to 5 with the bracket 1145 minus 1190 minus 1190. When you multiply all this number and we subtract this, we will get 85. Again 85 equals to 5 into 1145 minus 6 into 1190, and what you get at the end, therefore 85 is equal to 1190 multiplied by minus 6 plus 1145 multiplied by 5. So hence you can write m is equal to minus 6 and n is equal to 5, and this is the answer. Okay, this is the answer.